Hi everyone, this is Mrs. Eggerding again, and this is video 4 of our unit on systems of equations and matrices. We've been working with operations on matrices, and today's video is to introduce a new operation. It's called the determinant of a matrix. And so what I have up here for you is a 2 by 2 matrix A, and I've labeled these elements. The 1, 1 subscript stands for row 1, column 1. 1, 2 is row 1, column 2. The 2, 1 is row 2, column 1. And the 2, 2 is row 2, column 2. So these are elements of a matrix. The determinant is given by this symbol, absolute value bars. So when we're talking about matrices, when you see these absolute value bars, that means find the determinant. And the determinant is given by multiplying these diagonals. So I would take A11 times A22, and I'm also going to multiply along the other diagonal, A12 times A21, and you will subtract those two values. So if I write it out long ways, it's A11 times A22 minus A12 times A21. When you do that, you will get some sort of number. Okay? And so a determinant is some sort of real number that we can associate with a matrix. Its point will come out in a little bit later. Right now we're just working on the calculation part of it. So if we want to find a 2 by 2 determinant, you might see these directions. Find the determinant of, and it's a 2 by 2 matrix, negative 5, 9, 4, negative 1. And so we multiply the first diagonal, negative 5 times negative 1, subtract, multiplying the other diagonal, 9 times 4. If you do these calculations, you get 5 minus 36, which is negative 31. And so we say the value of the determinant is negative 31. This one here, I didn't say take the value, find the determinant, but I put the absolute value bars around it. This means, these bars mean find the determinant. Okay. So we'll go ahead and we'll multiply our diagonals. So take negative 5 times y, subtract, multiply the other diagonal, 2 times x. In this case, there's nothing to combine, so it's just negative 5y minus 2x, and that is the value of the determinant. If you want to, you can try to be clever and factor out a negative 1, but that's not necessary. Okay? Now when we get to a 3 by 3 determinant, things get a little bit messier, because if I were to multiply a diagonal and then multiply along another diagonal, I end up missing a bunch of values going around here. So we need to find a way that we won't miss any of these values. And we do this using a technique called minors, where we're going to create some 2 by 2 matrices by eliminating a row or a column. So we can create a minor by, say, eliminating a row and a column here. Say I pick all the ones with the 1s, and I've created a mini 2 by 2 matrix. Okay? It'll be easier to show you how it works on this example. So here's a 3 by 3, and I want you to find the determinant of matrix A. And I'm going to start by deciding which row and column, I'm going to start expanding. And I'm going to expand along this top row. And there are reasons why I'm choosing this one over the other ones, and I'll show you in a minute. So the first thing I'm going to do is, from this 1, cross out a row and the column that goes with it. And I'm left with a 2 by 2 matrix. Okay, so I'm going to write that 2 by 2 matrix down. 2, 1, negative 1, 4. And I am also going to put that 1 that I circled with it. Okay, I'm then going to do the same thing with the next value in that row. I'm going to cross off this row, cross off the column with the 2 in it, and I'm going to write down the 2 and take the determinant of what's left. So it's the negative 1, the 0, and the 4. So I crossed off the row with the 2, crossed off the column, put the 2 in front, and I'm going to do the determinant of what's left. Finally, I'm going to repeat it, and I'm going to expand where the 0 is. So I'm going to cross off the row and the column with the 0. I'm left with a 2 by 2 matrix, negative 1, 2, 0, 1, and I'm going to put a coefficient in front of it, 0. Now, this right here is a reason why I chose this row, because I knew I'd have to put these coefficients in front of my 2 by 2 determinants. If one of the coefficients is 0, I've just made my life a lot easier. Okay. The final thing we need to worry about here are the positive and negative values. If you remember from a 2 by 2, one diagonal was positive and one was negative. Well, here we're going to do the same thing. And so the signs on our 3 by 3 are going to follow a pattern depending on which row and column you are dealing with. Okay? And they're going to alternate positive, negative, positive, or negative, positive, negative, depending on which row you are in. Since we were in the top row, that's where I did the expansion by, I am going to use the signs positive, negative, positive to match this top row that I chose. Okay, so that's the setup for these. We'll do one again in a little bit. Once you have the setup, okay, I started with the 1 and I eliminated a row and a column, wrote the 2 by 2 that was left with the 1 in front. Then I went to the 2, eliminated the row and the column, made the 2 by 2 of what was left, put the 2 in front. Then I went to the 0, eliminated the row and the column, wrote the 2 by 2 of what was left, put the 0 in front. The signs come from this pattern, and since I used the top row, I did positive, negative, positive. I wrote positive, negative, positive. All that's left is the calculation. So here I have 1 times this 2 by 2 determinant is going to be 2 times 4 minus negative 1 times 1 minus 2, and this 2 by 2 determinant is negative 1 times 4 minus negative 1 times 0. These zeros are coming in nice, and on the end I don't even care about the determinant because it's going to be 0. Now I'm going to finish up the arithmetic here. It becomes 1 times 8 plus 1 minus 2 times negative 4 minus 0. That becomes 1 times 9 minus 2 times negative 4. So that becomes 9 plus 8, and my determinant is 17. Okay? When you get to the point where you have the 2 by 2's, it's all about the arithmetic. But setting up that expansion can be a little bit tricky. So let's try it one more time with this 3 by 3 matrix. Okay? I'm going to put my little cheat sheet here for the signs up at the top that I'll need. Okay? It'll be positive, negative, positive, negative, positive, negative, or positive, negative, positive. All right, I look at this 3 by 3 matrix and I'm trying to decide what's the best row to use, and I think I'm going to use this bottom row. Bottom row has a 0 in it. That's going to make my expansion a little bit easier. Okay, so I'm going to start with the 1 in front, bring that down, and then I'm going to have a 2 by 2 from crossing out that column, crossing out that row. The 2 by 2 that's left is negative 3, 2, 3, negative 2. Okay. Now I'm going to go ahead and set up the 0 as my coefficient. Put the 0 in front. The 2 by 2 that's left is 5, 2, negative 5, negative 2. I have one more left. Take the 1 as my coefficient. Cross off the row and the column. I'm left with a 2 by 2 of 5, negative 3, negative 5, 3. Since I used the bottom row, my signs are going to be positive, negative, positive. There's my setup. Now I'm going to do the calculations. This is going to be 1 times negative 3 times negative 2 minus 3 times 2 minus 0 plus 1. Multiply the diagonals. 5 times 3 minus negative 5 times negative 3. This becomes 6 minus 6. And this one becomes 15 minus 15. This whole determinant equals 0. And that is okay for a determinant to equal 0. Go back, rewind things if you need to see it, set up again. Okay? For the assignment, questions 1, 3, and 5 are practicing 2 by 2 determinants. 15, 23, 25, and 27 have you practicing the 3 by 3 determinants. Please make sure you check your answers in the back of the book before you go ahead and do the entrance slip. Tomorrow in class, we are going to be solving some equations using these 2 by 2 or the 3 by 3 determinants. So bring your questions to class or come visit us before school and we can chat. Good luck, and we'll talk to you later. Bye-bye.